Okay, so I did effects of teratogens on chick embryos. So we talked about this Monday, but a teratogen is a substance that disturbs the development of an embryo or fetus. Teratology is the study of the abnormalities in physical development, and main teratogens is lots of drugs. We looked at a list on Monday, and alcohol is one. So I looked at, it was an experiment that exposed chick embryos to ethanol vapors to see if it affected the hatchability and the developmental defects. So it was meant to, we talked about fetal alcohol syndrome, and so most of the time that happens when the pregnant woman is drinking alcohol. But they were trying to see if apparently inhaling alcohol vapors is a thing, if that would affect development of a embryo. So they ended up, they had two groups. So they had group A was the control, and then group B was the group that was exposed to ethanol vapors. So for each group, they killed a third of them at day 7, a third at day 10, and then the last ones they didn't kill and dissect until after day 22 or hatching, whichever came first, because chicks should normally hatch at day 21.
Okay, so the incubation period of chicken, now you're talking about chicken, is 21 days.
Mm-hmm. So the results basically that came out of this was for the control group that wasn't exposed to ethanol. Most of the chicks hatched on day 21. They didn't need They didn't need to be assisted while hatching, because a lot of the chicks, if they might have been able to like break the egg a little bit, but couldn't fully break the eggshell and get out. So 90% of the control group were active and healthy, which is what you would normally see when you're hatching chicks. The group that was exposed to ethanol, most of them didn't hatch until day 22, and most of them had to be assisted. They couldn't get out of the shell themselves. 33% of them had wobbly gait, staggering, and poor balance. 56% had diminished mobility and couldn't stand erect. And then 9 of them failed to retract the yolk sac. So chicks usually retract the yolk sac and use those nutrients for the first 2 days of life, and these chicks didn't, so it was just kind of there.
So yeah, let's go back to that retraction, because that's basically taking it into the body. You don't see it from the outside, but yeah. And by the way, the chicks get antibodies from that yolk sac, which is very interesting, from mom.
And then these are pictures. This one is the alcohol chicks, and as you can see, this one can't even stand all the way upright. And then here's one of the chicks where the yolk sac's still exposed because it didn't retract it. So basically in this study, they found that with the exposure to the ethanol vapors was an increased risk of developmental defects with increasing embryonic use and the longer duration of it, because they didn't really, when they dissected the chicks at day 7 and day 10, they didn't really see any changes. It wasn't until the ones that hatched they really saw any developmental defects. And then there was damage to the central nervous system and the skeletal muscle.
Ready for questions?
Yeah.
Tell me again how they did the vapor, and how was it continuous or?
So they had them in incubators. And so for the group that was dissected at day 7, they were exposed to the ethanol vapors. I'm fairly certain it was continuous from day 1 through 6.
Okay, 1 through 6, and then
and then the other 2 groups were exposed from days 1 to 9.
Oh, just 1 to 9.
This one 9.
Okay, I think you got a question. Question? Oh, okay. So that was a stretch. Okay. Anybody else have any questions? So, where was this done at? I guess I'm curious. Do you remember?
I can look it up really quick.
Okay, I was just curious if it was at some med school.
It was in Islamabad.
So, okay.
At a Department of Anatomy.
Okay.
Yep.
Okay. Very good. Thank you. Let's give her a round of applause. Okay, that's great. Super. Okay, so now this is an example of, and I guess were they trying to study, indirectly the situation in humans?
Yeah.
Okay. So here's what happens at a lot of med schools and other places. You don't do research usually on humans, right? So then you have animal models. and then maybe you try something and it leads to something else. Here's probably the most famous animal model for pregnant women, and I'm not sure how this came about. But pregnant sheep are a model for pregnant women. And remember on Monday I alluded to the fact that, the Jennifer that was one of my graduate students, she was interested in fetal alcohol syndrome. It's also called fetal alcohol spectrum. And I know one of the links, maybe we'll get to today, is that. And I started telling you about that. And since we just had a presentation on that, let me find that for you. Because I think I probably got some articles about it, but in my office, but we just moved. So let's see, Google, I want to do google.com. So let's see, here we go. Okay, so here's how you look this up. Ulrich, this is the weirdest thing, right? Ethanol, sheep. And no. Okay, let's see. This is, here it is right there. So there's Jennifer at the front there. And I should read the whole article because I don't remember exactly all the steps. Remember, she was working with a med school in Iowa State, not at Iowa State, University of Iowa. And we had 45 pregnant youth. I don't remember that many, but I guess we did. And the thing is, they got 1 gram of ethanol per kilogram maternal weight, 18. And this is something about experiments. Would you only inject ethanol in the group, like the one group that's going to get it? What would you do with the other group, the other groups that were, everybody was pregnant? What would you inject into the other animals? Would you inject anything? Saline, physiological saline. Because if you do something like injecting alcohol into an IV, and you have to handle them, right? I mean, it's very easy. You don't put them in a chute or anything. You just straddle the sheep and you get the jugular vein easy. But the thing is, you better handle all the animals and inject something in all the animals. Because maybe the act of injection and handling would cause some effect, right? So whatever volume it ended up being with the pregnant sheep that got the ethanol, I gave that volume of physiological saline, which is, tell me the recipe for physiological saline, if you ever had to make it up. And it was sterile. But somebody tell me the recipe for physiological saline. If you had to make it up right now, if you had the ingredients in front of you, tell me the ingredients and the amounts. Nobody can tell me that? And I can't take the chocolate back. 0.9% sodium chloride. 0.9% sodium chloride. That means 0.9 grams of NaCl per 100 grams of water. And 100 grams of water is 100 mils of water is 100 cc's of water. 1 gram of water, water, 1 gram, 1 mil, right? So you go 0.9 grams of sodium chloride per 100 mils. A lot of times you do it by liter. So then you do 9 grams of sodium chloride per liter. And then you would sterilize that. And you would inject all 45 sheep, some with alcohol, some with, I guess you could call it the control solution, also called the placebo solution, right? You better do that, and if you ever read an experiment where they do something to some group of animals and they don't do it to another, then the data is called confounded. C-O-N-F-O-U-N-D-E-D. Confounded. And too much data out there is confounded, where somebody does something and then, the other groups aren't treated the same. And then, okay, maybe it was just the act of handling the pregnant sheep and injecting something into their jugular vein. So, got to be careful about that. And I was telling you that we injected it. Then I forgot that she had collected the placentas, and she actually measured the size of the cotyledons. And let me enlarge that since we're doing a little anatomy here. Let's see. Does it say anything about cotyledons in this one? Maybe it doesn't. Again, vigor score. Oh, here it is, right here. Cotyledon. So that gets to be about the anatomy of sheep. On the placenta, there are these regions that are, I could show you a picture. Distinct areas on the placenta that attach to distinct areas on the uterus. And the structure that's on the placenta is called the cotyledon, and the structure that's on the uterine wall is called the carbuncle, and you spell it just like carbuncle. And then together, those make up the placentome. You do placenta and then T-O-M-E, the placentome. And she had measured I guess I forgot she did the weight and the diameter of the placenta. And then it doesn't say there, but of course most sheep will have more than one offspring, right? So might be 2 placentas to work with, whatever. Then she did videotape when they were born. And then I don't think it says there about the age, but then remember I talked about collecting the brains? I remember taking a bandsaw and cutting the heads open and taking the brains, and we sent the brains to the med school so they could section it and stain it and look at whatever. But there's a lot of interest in this fetal alcohol syndrome, fetal alcohol spectrum it's called. And so the chick thing is just another way of looking at that. Okay, so now let's do some more teratogens, and I know what. Yes, I did change this one. Remember that Monday the Purdue site didn't show up? They had changed their thing. Let me scroll down, and I'm not, to show you how extensive this list is. Look at supposedly all known teratogens, but they must have taken quite the liberal definition, because way down in the P's, and I know why they do this, because there's a lot of chemical labs on campus, and if you're a woman and you're pregnant and you're working with some of these things, but I was surprised to find, look at this, it goes on and on and on. I'm looking for progesterone. There it is right there. So that's a little weird to me, because progesterone is made by the CL and it helps for pregnancy. Maybe there's some studies that show exogenous progesterone might have some bad effects. I don't know. I just have a big question about that, because sometimes when animals are in danger of losing their pregnancy, you give them progesterone. So, it's quite the list, but there's probably 1,000 things there. Okay, I fixed that link anyway. Okay, so back here. Okay, that's the study of, you guys can read that. I don't really have to. Let's see, 4. Okay, let's open this up, and I can't remember doing this. Okay, so you can read that as well. I want to go to 5. Okay, thalidomide. This has got a very interesting story. I just have time to introduce a little bit. But this is a case, remember, okay, it goes back. Do you remember how most pharmaceutical companies, who do they test out all their drugs on usually? White young men. So all the dosages and other things are kind of like, somehow transferred over to other people. And then again, you don't do studies with pregnant women, but you could do studies with pregnant sheep, right? But somehow this drug, thalidomide, was used for morning sickness. And unbeknownst to them, it was a teratogen. And of course, you don't know this right away, right? It's not like, okay, we're going to give it today, and then we know it's tomorrow is a teratogen. You don't know until the babies are being born. And so, if you read this article, and this is a very famous teratogen, it has some terrible effects on the fetus, like morphological differences. I mean, there were kids that were really terribly deformed. And so, you can read on that. Sometimes it takes a while for the bad things to spread around the world. Now, when you see the thalidomide analogs, I haven't read that paragraph, but analog means what? Usually. You always name the parent compound first. You say thalidomide, and then you could say antagonist, agonist, analog. What's an analog? It's something that's structurally very close to the parent compound, ends up being. So, now, and the other thing is it may have similar actions, it may have no actions, it might have less, more. You just never know, and that's why you would do studies. So, I don't know if after this was found years ago, if they did some studies in sheep looking for some compound that was less toxic, but very famous bad thing to happen, and sometimes you don't know because you don't do research with pregnant women. Okay. So then that was 5, I think. 6. Diethylstilbestrol, abbreviated DES, all capital letters. This is look at that, synthetic non-steroidal estrogen. So that's very interesting. So an estrogen doesn't have to be a steroid, but endogenously all estrogens are steroids. But here's a case of, you could say, synthetic means it's being produced in a laboratory. Okay? Non-steroidal estrogen. Well, I can't remember what they originally prescribed it. Human exposure occurred. Okay, it was fed to cattle because it was supposed to be a growth promotant, make cattle more efficient. Okay, and it was given to pregnant women. There we go again, in the mistaken belief that it would reduce the risk of pregnancy complications. So the bad thing about years ago is they never tested it out, like, let's say, on pregnant sheep. They just maybe only tested it out on the young men, and then they said, it has estrogenic effect. So if something has an estrogenic effect, it's got to bind somehow to that receptor. That's the one thing you should know. So it's got a similar structure that somehow it fits in the lock, because that's not quite a steroid molecule up there, but I can see some similarities. So it fits in to the receptor, and then it was found out that it causes problems with the offspring. Okay. And there's it's got all kinds of, and this is a neat thing. So it messed up with the fetus of the mother that got the DES. And that's called the first generation effect. 3 million pregnant women were prescribed. Had risk. Okay, so anyway, the thing is, when the children were born, they had some problems. Further, they were going to have some reproductive problems. And that's called a second generation effect. Okay. And I'm just trying to look for the paragraph where it's got that. Anyway, so it has long-term effects that affected the women that were being treated, and then it also affected the offspring. And it looks like it wasn't sex confined, it was like even the sons had problems. So look at that, the diethylstilbestrol exposed males had an increased risk of testicular cancer when they grew up. So quite the long-term effects. A lot of animal science departments treated cattle with DES. Because when it first came out, before all these effects were known, they were using it to increase feed efficiency. Okay? And so, if you look in the literature, there's a lot of animal science data that, they fed it to cattle, and I think they had some effects, okay? And it might still have, there it is right there, growth promotion in cattle. Growth hormone and poultry. It was later found to cause cancer, okay, by 71, but was not phased out till 79, okay. So anyway, there it is. Okay, anybody got any questions? I'm going to stop there. Make sure you get your wrappers in the garbage. Take any extra chocolate. See you Monday with the 2 goats. Are the goats named at all?